In block diagram of a computer, we are going to get 4 different units. Dear students, from the examination point of view, the block diagram of a computer is very important. CPU is the brain of the computer that accepts data. Hello everybody, a warm welcome to my new session. We are on the 4th session of overview of a computer. I am Revati, faculty, Department of Computer Science, Vidhyaashram First Grade College, Mysore. Today's session, I am going to discuss the block diagram of a computer. Before going to start my session, I just want to recall the things which I covered in the last session. In the last session, I discussed the difference between analog computer and digital computer. Then I discussed the difference between mini computer and microcomputer. Then I discussed the difference between supercomputer and mainframe computer. Then we discussed the component of computer. Under component, we studied what is hardware, what is software, what is data, and what is user. Dear students, from the examination point of view, this is very important topic. Dear students, let's move on to the today's topic, that is block diagram of a computer. In block diagram of a computer, we are going to get 4 different units. In that first one, it is central processing unit. It is also called CPU. CPU includes ALU and CU. That means CPU includes arithmetic logic unit as well as control unit. The second unit is input unit. The third unit is output unit, and the fourth unit is storage unit. Dear students, every computer is made of 4 different elements, that is CPU, input, output, and storage unit. Moving on to the diagram. So this is the block diagram of a computer. Dear students, from the examination point of view, the block diagram of a computer is very important. So what are the units of computer? Computer includes 4 different units. In that first one, input, then CPU, then output, then memory units. What is input? So input from the user. So input from the user through keyboard or mouse. So example for input unit or input device is keyboard or mouse. So that input is given to the CPU. Now the CPU is responsible for processing the data. So inside the CPU, the control unit and ALU, that is arithmetic logic unit, is responsible for processing the data, and it is stored in the memory unit. And the processed output is sent back to the output device. So example for output device, here it is printer, or it may be a plotter, or it may be a monitor. And dear students, please remember that the input is given from input devices like keyboard and monitor to CPU, that is indicated by solid arrow. Now, the received input is processed by the control unit as well as arithmetic and logic unit. This comes under CPU. So, the data is travel from memory to control unit to AL, from AL to control unit, and from control unit to memory. So it is a circular fashion. The output is given to output device. The example for output device, here it is monitor, printer, plotter, etc. Dear students, some of the example for secondary storage devices are magnetic tape, magnetic disk, and CD. These are the example for secondary storage device. So the CPU is also responsible for accessing or receiving the data from secondary storage device. Let's discuss the elements one by one. The first and very important element here, it is central processing unit. What is CPU? What is the job of the CPU? So here CPU is the brain of computer. So CPU is called brain of computer because CPU is responsible for accepting the data, perform the operations on the data and send the result to the user. Dear students, I repeat, CPU is the brain of the computer that accepts data from the user or from the keyboard or from the memory, okay, and performs all the operations on the data and sends out the result. So the information or data from input devices or from the computer memory is communicated via the bus. Here, bus is nothing but a communicating system. I repeat, here bus is nothing but a communicating system used to send and used to receive the data within the computer system. So what is the responsibility of central process unit? The information from an input device or from the computer memory is communicated via the bus to the central processing unit. The CPU includes 4 components. CPU consists of ALU, that means arithmetic logic unit, and control unit or CU. CPU also has some set of registers. So these registers are mainly used for temporary storage purpose. So CPU is also called brain of computer and it is responsible for accepting the data, performing the operation and sending the result. So accepting the data or sending the result from memory to display unit or input device to computer is carried out through some communication channel that is called bus. CPU also contains some register. Registers are the temporary storage area. Moving on to the block diagram of central processing unit. So CPU includes central unit. Then CPU also includes arithmetic and logic unit. CPU also includes registers. CPU includes 5 different types of register. In that, first one, it is program counter. Then next register is current instruction register, then accumulator, then we have memory address register, then we have memory data register. So each CPU includes CU, that is central unit, then arithmetic logic unit, that is ALU, then register. Under register, we are going to get 5 different register. Moving on to the ALU, that is arithmetic logic unit. So arithmetic logic unit includes 2 units, that is arithmetic unit and logic unit. Here arithmetic unit is responsible for performing all kinds of arithmetic operations. For example, addition, subtraction, multiplication and division. Where logic unit is responsible for performing all kinds of logical operations. The logic unit is responsible for performing logic operation and it is also responsible for performing comparison of 2 numbers or letters and special character. At the same time, logic operation includes testing for greater than or smaller than or equal. ALU is responsible for performing arithmetic and logic operation. Before going to perform arithmetic and logic operation, the data is stored in the register. So, the register is used to hold the data that is being processed. So, I repeat, ALU consists of two units, that is arithmetic unit and logic unit. Here arithmetic unit is responsible for performing all arithmetic operations, where logical unit is responsible for performing all logical operations like comparing numbers, comparing characters, comparing special characters, etc. At the same time, it is also responsible for testing greater than, less than or equal to. ALU performs arithmetic and logic operation and uses register to hold the data that is being processed. Before going to perform arithmetic and logic operation, the data must be present in the register. Moving on to the control unit, that is also called CU. Dear students, let's see the responsibilities of control unit. What is the first responsibility? Here, control unit is responsible for organize the processing of data and instruction. I repeat, here control unit is responsible for organizing the data and instruction. Here control unit act as a supervisor and controls and coordinates all the activities of the other units of computer. Now this control unit act as a supervisor. It is going to control and coordinate all the activities of computer system. The control unit is also responsible for coordinating input and output device. So, control unit is also responsible for directing the computer system to carry out the stored program instructions by communicating with the ALU and register. I repeat, the control unit is also responsible for directing the computer to carry out stored instruction by communicating with CPU with register. So, control unit tells when to fetch the data and instruction. So, here control unit is going to give the instruction that when to fetch the data and instruction. So, this control unit is also responsible for instructing what to do and where to store the data or instruction. And it is also responsible for the sequencing of events during processing. So, these are the some of the responsibilities of control unit. I repeat, control unit is responsible for instructing the system. So, control unit tells when to fetch the data and instruction and where to store and what to do. At the same time, it is also responsible for sequencing of events during processing of data. The control unit is also holds the CPU instruction set, which is a list of all operations that the CPU can perform. Here, control unit holds the CPU instruction set. Here, CPU instruction set contains the list of operations that the CPU can perform. The control unit is responsible for organizing and processing of data and instruction. It acts as a supervisor. It is going to control all the activities inside the CPU. Dear students, moving on to the register. What is register? Here register is nothing but a high-speed storage area. It is nothing but a high-speed storage area which is present inside the CPU. But it is going to have very small storage capacity. Registers are not referred by their address, but they are directly accessed and manipulated by the CPU during the instruction execution. That means during the execution of the instruction, the register contents are directly accessed. Here, registers are used to store the data. Registers are used to store the instruction. It is also used to store the address and intermediate results. I repeat, registers are used to store the data, instruction, address and intermediate result. And registers are often referred as the CPU's working memory. I repeat, these registers are often or frequently referred as the CPU's working memory. So, the data or instruction that required processing that must be brought into the register of CPU before they can processed. Consider the example. Think that you want to add two numbers. So before going to add, the two numbers must be brought into the register. Then perform addition operation, then store the result in the register. So here register is nothing but a storage area, or it is a temporary storage area, and it has got high speed. So it is called high speed storage area, and the storage capacity is very less. Before going to execute any data or any instruction, the data and instruction must be carried into the register. Dear students, moving on to the type of register. Here each register is responsible for different purpose, with each register serving a specific purpose. That means each register is responsible for some specific purpose. Dear students, we are going to get 5 different types of register, and each is responsible for specific task. In that first one, memory address register. It is responsible for holding the memory location of data that needs to be accessed. So here memory address registers are used to hold the memory location address of the data that needs to be accessed. Dear students, the another type of register here, it is memory data register. It holds the data. I repeat, the memory data register holds the data that is being transferred from R to the memory. I repeat, it holds the data that is being transferred from R to the memory. The another type of register here, it is accumulator. What is the job of the accumulator? Where immediate arithmetic and logical results are stored. So here accumulator registers are mainly used to store the result which is performed during arithmetic and logic operation. The fourth register, it is PC. That means program counter. So here program counters the address of the next instruction to be executed. Here program counter is used to hold the address of the next instruction to be executed. The last register here, it is current instruction register. It is called CIR. So CIR contains the current instruction during processing. So the CIR contains the address of current instruction that is being processed. It is responsible for holding current instruction address. Registers are the temporary storage area, and we are going to get 5 different registers, and each register is capable to do their own specific task. So in that, memory address register, memory data register, accumulator, program counter, and current instruction register. Dear students, moving on to the memory unit. What is memory unit? It is a storage area that provides storage space for data and information. So memory consists of cache memory and primary memory. What is cache memory? It is a very high speed memory, and it is placed between RAM and CPU. What is RAM? That is random access memory. Cache memory increases the processing speed. Moving on to primary memory. Primary memory is also called main memory. I repeat, primary memory is also called main memory. So this main memory is used to store the data and instruction during execution of the instruction. I repeat, this main memory is mainly used to store the data and instructions during the execution of the instruction. Cache memory is a very high speed memory, and it is placed between RAM and CPU, whereas primary memory is also called main memory of the computer, and it is used to store the data and instruction during the execution of the instruction. The two types of primary memories are random access memory and read-only memory. In the upcoming session, we are going to study in depth about random access memory and read-only memory. Then we are going to get secondary memory. This secondary memory is also called non-volatile, and it is used for permanent storage of data and instruction. I repeat, secondary memory is also called non-volatile, and it is mainly used to store the data permanently. A program or data that has to be executed is brought into the RAM from the secondary memory. Suppose if you want to execute any program or any instruction, that must be brought into the RAM from the secondary memory. We know that all the data files are stored in the secondary storage area. So before going to execute, that particular file is brought from secondary storage to RAM, that is random access memory. Moving on to the next very important component of computer, that is input device. So input device which allows the user and other application to input the data to the program into the computer. The input device is the way that the user can able to input the data or instruction to the computer system. So here input devices are classified into two types, that is human data entry device and source data entry device. So I repeat, here input devices are classified into two types. One is human data entry device and another one source data entry device. So in the human data entry device, we are going to get keyboard, pointing device, tablet and pick device. In the source data entry device, we are going to get audio input, video input, scanner and optical scanner. Anyway, I am going to explain human data entry device and source data entry device in the next session. So, input device is nothing but a device used to provide the input to the program. So, some of the example for input device is keyboard and mouse. So, these are the two input device most frequently used to input the data. Moving on to the output device. So, what is the job of the output device is to provide the output to the user. So, here output device provides output to the user which is generated after processing the input data. So, the most common devices are here hard copy devices and soft copy devices. Suppose if you want to get the output in some hard copy, then you can use printer and plotter. So, some of the example for soft copy devices are monitor, visual display terminal, video output and audio response. Here output device is mainly used to output the result to the user. The most common output devices are monitor and printer. Dear students, today's class we studied the block diagram of a computer. In block diagram of a computer we studied central processing unit, then we studied input device, then we studied output device. Then we studied memory units. Dear students, from the examination point of view, this carries weightage. Dear students, in the next class, I am going to discuss limitation of computers and data organization. Dear students, I hope in the today's class you got more information about the computer system. Dear students, this is all about today's session. Let's meet in the next session. Until then, take care. Thank you.